Now we are going to start a new topic, that is electrochemical cell. Do you have any doubt from the previous class?
Sir, can you explain that laws?
Were you absent in the last class?
Yeah.
Oh. So basically, I taught from this topic variation of molar conductivity and equivalent conductivity with concentration or dilution. Basically, with dilution, if you are going to dilute a weak electrolyte or a strong electrolyte, what will be the variation of equivalent conductivity or molar conductivity? So basically, when you are going to dilute, do you know what dilute means?
Making something weak.
Making something weak. What does this mean? Dilution here means you are going to mix it with solvent, or you can say if you have concentrated acid or base, you are going to mix it with water. If you are going to increase the concentration of water or the volume of water, it will be diluted. That means indirectly, that means that a strong acid or base will be weak. Is that clear?
Yes, sir.
Now see, this weak electrolyte, if you are going to dilute it, that means you are going to add some water. And if you are going to add water, that means volume of the solution will increase. And if volume of solution will increase, the distance between the weak electrolyte particles will increase. That means force of attraction between them decreases. Yes or no?
Yes, sir.
And if the force of attraction between them decreases, that means they can easily move faster than the earlier. And if they can move faster, that means conductance will increase. Is that clear?
Yes, sir.
In the same way, for a strong electrolyte, if you are going to dilute it, volume increases, force of attraction decreases, conductance increases. But here we are going to study about variation. So see, in weak electrolyte, if you are going to do a lot of dilution, so first of all, you need to know what is weak electrolyte. Weak electrolyte, generally, the dissociation is very small. That means if you have weak electrolyte, it's the value of alpha, its alpha's value will be 5% max. If you have 100 molarity, that means it will dissociate only 5 molarity. 5 molarity will be converted into product. But in case of a strong electrolyte, alpha means 100%. All the strong electrolyte will be converted into its ions. But here in weak electrolyte, due to more and more dilution, the dissociation, the value of alpha increases. That means new ions will be generated. That's why the variation in weak electrolyte will be higher than the variation in a strong electrolyte. Are you getting my point?
Yes, sir.
So what I want to say is that in weak electrolyte, new ions will be generated. That's why the conductance will be abruptly very high as compared to a strong electrolyte. Because in a strong electrolyte, if you are going to dilute with a small quantity of water, all the ions will be converted, all the electrolytes will be converted into ions. And if you are going to dilute it more, only the distance between the particles will increase and the force of attraction decreases and conductance increases. But in case of weak electrolytes, new ions will be generated and conductance will be very high. So the variation, if you are going to see, will be like this. This is a weak electrolyte, this is a strong electrolyte, and the variation you can see is very high in case of weak electrolyte as compared to a strong electrolyte. Now we are going to see molar conductivity and equivalent conductivity, because the topic was not for conductance, but it is for conductivity, molar conductivity and equivalent conductivity. First of all, you need to know this equivalent conductivity will decrease with increase in dilution. That means conductivity, basically, if you are going to increase the volume or if you are going to dilute more and more, the conductivity will decrease. How it happens? Basically, conductivity is defined as conductance due to all the ions present in 1 ml electrolyte. So basically it depends on the density. Density is equal to mass upon volume, and you know that if you are going to dilute it, volume increases, and volume increases, that means density decreases, and if density decreases, uh, sorry, I was just disconnected. Who's the host here? Okay, I'm host. So Rim, did you get it all?
Kind of say,
What is conductivity? So see, basically conductivity depends on density, and you know that if you are going to dilute it, volume increases, density decreases. Now we will talk about molar conductivity has formula this, and equivalent conductivity has a formula this. This we have already discussed. Now molar conductivity is equal to kappa, that means conductivity into 1000 upon molarity. Now you know that if you are going to dilute it, kappa will decrease, and if kappa will decrease, that means molar conductivity will also decrease. But you know that molarity is equal to number of moles of solute upon volume of solution. If volume is increasing, that means molarity decreases, and if here molarity decreasing, that means molar conductivity should increase. Is that clear, Rim? Rim, is that clear?
yes, sir.
Now see, so basically how we are going to decide whether molar conductivity or equivalent conductivity will increase or decrease. So basically there is experimentally we saw that molar conductivity or equivalent conductivity depends more on molarity or normality than conductivity. That's why when molarity decreases with dilution or when normality decreases with dilution, molar conductivity and equivalent conductivity will increase. Is that clear?
Yes, sir.
Now after this, there was a Huckel rule from this graph. This Huckel rule is only for a strong electrolyte, and this graph is basically based on y is equal to mx plus c. That is for a straight line. So lambda m, that is molar conductivity at concentration C, is equal to lambda m infinity minus b under root c. C is for concentration, and lambda m infinity is for molar conductivity at infinite dilution, and b is constant. And this is called Debye-Huckel equation, and this equation is only for a strong electrolyte. Always remember that. Is that clear?
Yes, sir.
Now the next law comes out to be Kohlraush law of independent migration of ions, or we can simply call it Kohlraush law. This law is applicable for a strong as well as weak electrolyte. What does this law say is that if you have an electrolyte, whether it is a strong electrolyte or weak electrolyte, just suppose if you have AX BY, and if you are going to dissociate it, it will be XA plus Y plus YB X minus. It will be like this or not?
Yes, sir.
So basically, the equivalent conductivity of this, that I'm going to write EX for AXBY, the infinite equivalent conductivity of this will equal to lambda equivalent of this cation plus anion, equivalent conductivity of cation plus anion. But if you are going to talk about molar conductivity, so molar conductivity of this AXBY will be equal to whatever is the stoichiometric coefficient of this will be multiplied into this, and whatever is the stoichiometric coefficient of this will be multiplied into this. From class 11th, we know that molar conductivity is based on mole concept, and in mole concept we need to balance all the equations. To get the answer, you need to balance, and for that we just balanced it by multiplying it by x and y. But in equivalent concept, we don't need to balance anything. So that's why I just did this. Okay, is that clear?
Yes, sir.
This was it, and I have given some questions like this and this. And after this, I need to give you a question, and after that, I'm going to start the topic electrochemical cell. Okay, Samia.
Okay, sir.
Yes, sir.
Samia, you were present in the last class, right? Or absent?
Well, I was present, but I got disconnected afterwards.
Okay, so do you have any doubt?
No, sir.
Okay. So I'm going to give some questions on this, and then we will move to the next chapter. Calculate lambda naught m for calcium chloride CaCl2 MgSO4, that is magnesium sulfate, from wait a minute. And it is given that lambda naught Ca plus 2 has a value 190 Siemens centimeter square per mole. This chapter is very important, and lambda naught Cl minus has a value 76.3 Siemens centimeter square per mole. Also, it is given that about MgSO4, lambda naught Mg plus 2 has a value that is 106 Siemens centimeter square per mole. And lambda naught SO4 minus 2 has a value 167 centimeter square per. So this is the question. Can you do this or I should explain it?
Sir, I did that MgSO4 one.
Okay, what is your answer?
266 centimeter
Very
square.
good.
But for
S seen
calcium,
in centimeter square.
yeah, for calcium, I'm not getting.
Calcium, you are not getting. You got the answer for CaCl2, right? No,
No.
no, no. So it's very easy. So if you are going to do this, you can see lambda naught CaCl2 will be equal to, if you are going to dissociate it, since we are talking about M is for molarity, so it will be Ca plus 2 or 2Cl minus, yes or no?
Yes, sir.
So lambda naught M for Ca plus 2 plus 2 into lambda naught M Cl minus. So you can see lambda naught plus has a value that is 109 plus 2 into 76.3. So this will be, you can calculate this. Yes, Samia, are you ready?
Yes, sir.
So please do this and let me know if you're done with this. I'll give you another question.
Sir, is it 271.6?
200.
271.6.
Very good. Samia, you are also done with this?
Yes, sir. I got the same answer.
Okay. I'm going to give you another question. So the question is basically lambda naught m for NaCl, HCl, and NaSc are 126.4, 425.9, and 91 Siemens centimeter square per mole, respectively. Calculate lambda naught for HAC. Please do this. Yes, Samia, see. Rim, are
Yes,
you
sir.
there?
Yeah.
Now, how we are going to calculate it? Since we need the lambda naught m for HAC, okay, and this is NaCl, HCl, and NaSc. So what I'm going to do is just dissociate it. So it will be lambda naught m for Na plus lambda naught m for Cl minus. Can I write this like this?
Yes, sir.
Yes.
Now, same for HCl. It will be equal to lambda naught m for H plus lambda naught m for Cl minus. Okay. In the same way, lambda naught m for NaSc, it will be equal to lambda naught m for Na plus lambda naught m for Ac minus. Okay. Now see, I'm going to make an equation. Prepare this. How we are going to make HAC? Now you know that lambda m naught for HAC will be equal to lambda naught m for H plus lambda naught m for AC minus. Yes or no? Can I write
Yes,
it
sir.
like this? Now
Yeah.
see, we need H plus, so we will get H plus from here and AC minus from here. What we need to do is now 1, 2, 3. So if you are going to add 2 plus 3, and we get along with this Cl minus and Na plus, that we don't need. So I'm going to subtract it from 1. So the answer will be like this. What I just did is lambda naught m HCl plus lambda naught m NaSc minus lambda naught m NaCl. So what you get will be equal to, you can see lambda naught m H plus lambda naught m Cl minus plus lambda naught m Na plus lambda naught m Ac minus, and minus the first equation, that will be equal to Na plus and minus lambda naught m Cl minus. Now you can easily see this is plus, this is minus, so it will be cancelled. What we have left is lambda naught m H plus lambda naught m AC minus, which will be equal to lambda naught m H AC. So what we did is, what is the value of this? It was given in the question. What is the value of lambda naught m? Wait a minute. So you can see this has a value, NaCl has a value 126.4, this has a value 425.9, this has a value 91. So I'm going to just put the value. I'm going to put the value. NaCl has a value, HCl has a value 425.9 plus 91 minus 126.4 is your answer. Okay.
Okay, sir.
Please write this. Do I need to slide it up?
No, sir.
Okay. Let me know when you are done with this.
Done, sir.
Very good. Sani, are you done
Sir,
with this?
why are we taking?
Why are we taking? Sani, are you there? Samia. Samia, am I audible to you? Rim?
Yes, sir, you're audible.
Okay. Rim, I'm going to share a new page. Is it visible in the new one?
Yeah, sir, it is visible.
Thank you. Please try the sixth question.
Okay.
Can you do this or I should explain?
Sir, I can do this.
Okay, please do it.
Sir, option D.
Very good. Please do this 11th question. Samia, what were you asking? Samia, so I'll explain it soon. Wait a minute, Rim. So why we did equation 2 plus 3 minus 1 is that you can see, first of all, what we need to calculate is lambda not m for HAC, right, Samia? So when you are going to dissociate it, you will see H plus and AC minus. So search for H plus and AC minus here, H plus in the second equation and AC minus in the third equation. That's why I added it so that we get H plus and AC minus. Along with this H plus and AC minus, we got Cl minus and Na plus, that is extra. So in to remove this Na plus and Cl minus, we just subtract it from this. Okay. So you can see when I added 2 plus 3 minus 1, what we did is this Cl minus Na plus will be cancelled with the first equation and we got only this which has a value this. Is this clear, Samia? Samia, yes or no? Okay, thank you. Now I'm going to share that page. This. Samia, try this question number 7. Sorry, 6 and then 11.
Sir, for 11th one, A.
Very good. Just wait for a few minutes. Sania will be done with this, then we will go with next. Samia, are you done with this?
Yes, sir. For D, for sixth one, it's D.
B,
D.
D. Okay. And for 11?
Sir, I did not do that.
Please do this. Rim and Samia. Question number 13. Any answer?
I'm still doing that one, sir.
Okay. Please let me know if you have any doubt.
Sir, is it 389.71?
390.71.
89.71.
That is C, right?
Yeah.
Very good. Samia, what about your answer? Samia. Samia is not there. Okay, Rim. Question number 8. Rim, can you do the question number 8?
No, sir. Can you explain?
See, which of the following expression correctly represents equivalent conductance? See, equivalent conductance. So in equivalent conduction with conductance, if you are going to dissociate it, you will see it will be like this: 2Al plus 3 plus 3SO4 minus 2. Yes or no?
Yes, sir.
But we don't need to balance. We don't balance in equivalent concept. So the answer will be C. If see, basically, if you are going to do this Al2SO4 whole thrice, so it will be dissociated like this. Not if you are going to multiply it by 2 and multiply it by 3. If you are going to do this, it will be the value of molar conductivity, not equivalent conductivity. In the same way that I have just explained in the beginning of the class, AX BY. In molar conductivity, we need to balance, and in equivalent conductivity, we don't balance. Are you getting my point?
Yes.
Okay. So this is basically Kohlraush law and all. Now I want you to do some more questions like, please do this question. 12. 12 is basically based on your conductance, conductivity and all. Can you do this or I should explain?
Can you explain, sir?
See, I'm going to explain. First of all, what is given? Just concentrate on that one. 0.1 N, that means normality given. Also, this is a specific conductance, that means conductivity is given, kappa. Resistance of cell is this given, resistance given, cell constant we need to calculate. For cell constant, if you remember, I have written that kappa is equal to G into G star. This is cell constant, this is conductivity, this is conductance. Yes or no?
Yes, sir.
Now, you know that conductivity is inverse of resistivity. Wait a minute. Since resistivity is not given, that's why I just erased it. So cell constant will be equal to kappa upon G. Yes or no? G is conductance, and you know that G is equal to 1 by R. Yes or no? So G star will be equal to K upon 1 by R. Why I just did it in terms of R? Because resistance is given. So kappa into R. So kappa is given as 0.012, 0.012, and resistance is given as 55. Just multiply it and you will get your answer. Got it, or do you need another explanation of this?
No, sir.
Okay. Let me know when you are done with this.
Sir, B is the answer, right?
Yeah.
I'm done.
Okay. Now try question number 14. 14 is also very easy. Please do this. I'm waiting.
Sir, D.
D.
Yeah.
Wait a minute. Question number 14, right? D.
Yeah.
Very good. So go for question number 9. We haven't studied alpha yet, so just leave it. I'll explain this term, then we will go for this. Okay.
Okay, sir.
Now question number 5. Sorry, wait a minute. Question number 1 first, so that every concept of this and every type of question on Kohlraush law we just covered.
Sir, A.
Very good. If you're done with question number 1, question number 5. Will you be able to solve it?
I'll try, sir.
Okay.
Sir, can you explain?
Yeah, it's very easy. Just dissociate it first. It will be converted into NH4 positive and OH minus. Yes or no? Lambda, just write it. Are you getting my point? Now just dissociate all this. Or you can take lambda naught M NH4Cl and then dissociate it separately. Lambda naught M NH4 positive plus lambda naught M Cl minus. Are you getting my point? Then again you will take NaCl and then NaOH and make sure you are going to make this NH4OH. Rim, got it, or I should explain it in more detail way?
Got it, sir.
Very good.
I'm going out, so can I leave?
Okay. Can you do this or after this or before this?
I can do this, then I'll leave the class.
Okay.
Sir, D is the right answer, right?
Very good.